Hi, how are you? I hope you are doing good. My name is Preetham, and I'm a scientist at Stanford, as you can see from my badge. And this is my campus where I sit. This is called Center of Academic Medicine. This is where I sit and do all my research, and I also make my videos as well. So, welcome to my new channel. Um, my channel name is Omixium or Omixium. I don't know. Let's be real. ChatGPT named it, so blame the bot. So this is the first time that you'll see my face. You don't see my face everywhere in each and every videos, unless I'm Brad Pitt holding a pipette. You want to see the jawline of Brad Pitt, not mine. This is my fat face. You don't want to see my fat face either. So yeah, so let's be serious about the videos that I'm going to make on AI based drug designing, molecular docking, molecular dynamics simulations, genomics, NGS, bioinformatics pipeline, etc. So that will be my whole idea of this channel, to make these videos. I have my other channel, which is Bioinformatics Copilot, which I think you might have known about that. So there was some issue with that channel, so I'll be shutting it down, or maybe I'll keep it, but I won't upload my videos on that channel. So this is my new channel, so please subscribe to my new channel, and see you on the other side. Thank you very much. So you can visit to the website called AutoDockFR homepage, and this was a protein ligand program developed by Scripps Research Institute, and it uses Autodock 4 algorithm under the Autodock umbrella, and it can be used for flexible docking and also for covalent docking as well. And you can go to the downloads page and download the distribution for your Linux machine, for your Windows machine. I think for Mac OS it's kind of difficult. So for the Linux machine, what you can do is you can install it by opening the command line, and then use the command /ADFR, your Linux suite that you have downloaded, and then you can install ADFR in your home directory. Once it is installed, you can verify the ADFR installation by using the command called ADFR, and it will pop up. The help file will pop up. Okay, and then let's go to the documentation where we can do the first rigid docking using ADFR. So for that case, I have prepared a folder where I have a ligand and the receptor PDBQT file. Remember, you need PDBQT file for this, and you can check the installation by ADFR and AGFR. And there is also a graphical user interface which is called AGFR GUI, which is installed along with ADFR. So you go to the receptor and input the receptor.pdbqt, which is your protein file. Okay, and then you head to the ligand, which is your ligand.pdbqt file. Okay. So after loading both the protein and the ligand, you can zoom in, zoom out, you can see the entire box, and even the residues also you can pinpoint by using AGFR GUI. There are four options. The first one is defining the grid box for the whole protein. The second one is for the ligand. If you have a ligand in place in the protein, then you can select the second option where it can give you the grid box. And also you have a padding options where you can increase the padding and decrease the padding. But if you don't know the ligand binding site somehow, then you have this third option where you can choose all the residues that that might be involved in the binding site, and you can choose whatever the residues are there. And if you have a ligand in place, then you can choose this button where you can define your box within a certain angstrom, like 3 angstrom or 4 angstrom. But if you know the residues, that would be really great. The binding residues, then you can define the box. In a similar way, for this tutorial purpose, I'll be choosing the ligand and the box, which is already present in the binding site. And then you have also an option to define the grid also, which is the fourth option. Okay, that I will cover in the next video. Then you calculate the auto site, which is again another Autodock type of tool, where you first prepare the grid box and you define what is the binding site. It's like a CASP program, but AutoSite is a program for ADFR. Based on the volume of the residues or the volume of the grid box that you have chosen, you can define your AutoSite algorithm to generate the grid box alongside. Okay, and you select all atom types for this, so that you have all the atom types. Then you go to look at then it will create a TRG file, and there is a command called about, so you can type in about pocket.trg. It will tell you all the parameters that has been used to generate the grid box, and if you can extract it, then you will find all the map files which is generally used for Autodock tools. Okay, so if you open the bound.dat file, you have all the parameters over here, and the map files, which is like manganese, iron, zinc, you have everything over here. So you don't need to worry about generating a specific map type for each one of them. So it will automatically generate all the files for you, along with the rigid receptor as well. Okay, and then you have these three files: TRG file, receptor PDBQT, and ligand PDBQT. Then you go directly to the documentation where you can dock the ligand. So I will copy this and I will paste it over here. Then I just need to change only the ligand file. -L is for the ligand, where you can input ligand.pdbqt, and your -t is your pocket, which is pocket.trg file, which contains all the map files. Job name is rigid, NB runs is 8 times, and max evolution is 20,000, and seed 1. Then press enter. It will be done very fast because the grid box is small, and you have your affinity, which is -4.4 and -3.5. Then it creates a DRO file, which you can also check by using the command called about ligand rigid.dro, which will also tell you what are the parameters that has been used to do the docking, the rigid docking. And you have a summary file which is called ligand rigid summary.dlz. You have the entropy, and you have the types and what are the parameters used. Okay, then you can head over to the DLG file, and you can see all the information over here, how the ADFR has run for the rigid docking. And you can open the ligand.out PDBQT file in Chimera X, and you can view the poses. And you can compare it with your original ligand file, which is ligand.pdbqt, and then you can load the receptor to see where it binds. And this is how you do rigid docking using ADFR, which is much more easier in comparison to ADT tools, because you have to generate one by one. But this has been very useful to generate the maps, especially for the Autodock tools. And I think it's one of the easiest way that you can analyze it. In the next video, I'll be teaching about flexible receptor, how to generate. So just a quick overview how you can define flexible residues is the same way that I did, but the only option is you load your receptor file, you load your ligand file, and there is an option called flexible residues. You define the grid box, and then you define your flexible residues over here. And within that grid box, whatever the residues that are present in that particular grid box will be displayed here, and you choose which are the residues that are selected for flexible docking. And that's it. So it's very easy. Make sure you follow my channel. And this is my new channel. So you have been following my Bioinformatics Copilot channel, but there were some issues with that. So I have opened another channel. So please subscribe to my channel, and please let me know in the comments what are the videos that you would like to see. Thank you very much.